Good evening, my warriors. I hope you guys are full of josh for the next session of current electricity. Now, in the first session, we have spoken about resistance, what does it depend on, the formula, conductivity, then the resistivity formula, the dependence of temperature or resistance. And then we have also seen Ohm's law, and we have seen how current and voltage, affect each other based on their resistance. Now today we are going to talk about power losses, heat given by a circuit, and then a lot of problems and different tricks and techniques to find out equivalent resistance. Not just those simple series as well as parallel resistances, but also a different combination. So welcome aboard. This is Shreyas here, your master teacher for physics. Yes, it is called Ohm's Law, says V Enthuse FC. And by the way, V Enthuse FC fan club, I have just gone to the admin settings and I have unblocked all the accounts which you are blocked. Okay, so I hope that makes your day. Hi Aishwarya, hi Mohammed, hi Music Stories, hi Rajaram, hello Nancy, hello Harsha, hi Ankit, hi Minion Aarti, hello Music Stories, welcome, hi Neha, glad you are unblocked again. Okay, so hi Naomi, Prem, Arvind, Shreyas Kapri, Suday. Yes, good evening, good evening. Chapter ended. Arvind Arora motivation, sir. Are bhai, the chapter has just started. More 2-3 lectures, bacha. This is not one short series. This is Pathfinder series. In Pathfinder series, you have regular sessions, in-depth, problem solving, concept explanation of the entire 12th standard syllabus. So this is for all the 12th standard syllabus. So guys, go ahead, hit the like button out there to show your support, to show your love for me. Please do that. It means a lot when you hit the like button. And do not forget, if you are new to this channel, hit the subscribe button. And remember, the entire PDF is available in the Telegram group link, which is posted in the description box below. Good evening, Vikram. Hello, Abhijit. No problem. You're not so late, bacha. Don't worry. And by the way, this is the schedule for the entire week out here. Right from Monday till Saturday, a very special session I have planned for all of you this Saturday, guys. Yes, this Saturday there is a very special session. You can have a look. Now, what is that going to be? I'll let you know very soon. Don't worry about it. But remember, there is another session of Kirchhoff's current law, voltage law, and Wheatstone's bridge. That's on Friday. All my lectures are at 7:30, except for the ones in the morning at 9 o'clock. You can see the ones in 9 o'clock. That is for 2021 students, the Zero to Hero series. Okay, and the ones in white on Tuesday and Thursday, that's for 2023 students. And there is a Menti quiz up on Thursday on units and dimensions, errors, and basic maths for all the 11th standard students. Well, you can also go there and maybe you can get some nice pointers, because I'm pretty sure it will be easy for you. Okay, so having said that, I had also given you guys a homework last lecture, and let's just have a look at how many people have commented on the previous homework. Hi Mr. Hollywood, hi Shweta S, welcome aboard. PYQ for electrostatics, we'll do that, Venkata, in after Zero to Hero series. Definitely we are going to do that. And if you go to the past videos and out here, where are we? Yes, current, density and electricity. Yes, there we go. Okay, let's just pause this and let's see our beautiful warriors. Yes, Ankit Kumar saying yes, should I include diagrams? Yes, I have replied to you. V Enthuse fan club says hey sir, hey. And he has also posted the answer. Okay, Yamini has a doubt. Definitely Yamini, I'll answer that after the session. And Rohan, Minion Aarti, Roshan, Aishwarya, Sonu has something. Okay, I have repeated it and I have also posted it. And Sonu, I have also replied to your comment out there. And Music Stories, very good. And Roshan and Hasni asked what is E? E is electron charge. Okay, so come on guys, you need to post all the answers of all the questions out there in the comment section out there. Yeah, please do that. Okay, hi Klee Tsunami, welcome aboard. Hi Richa Roy. Yes, the Zero to Hero will happen in the morning. Yes, Richa, that's how it is. Butter era has started. Okay. Great, this is butter era. Okay, I don't know what was it before this. Was it cheese? Was it something else? I don't know. So yes, I'm very good. Thank you very much. Okay, chalo, let's get going. And it's a mathematical relation between current passing through a resistance. I'm not sure, Ankit, which point you're referring to. Okay. Yes, I'm still watching lecture 1, Vijay Kumar. Come on, hurry up. And all those guys who are still stuck in maybe electrostatics or maybe Gauss's law, please hurry up. You need to buckle up and come up to date, come to speed, because you need to watch all the lectures live. If you're watching just recordings, it's good if you cannot attend the live classes, but I feel the fun of live classes is completely different, and I'm pretty sure you guys also have a gala time in the chat box. Come on, introduce each other, introduce all your friends, get to know each other, help each other, support each other, and block all the viruses that might come in our chat box. Okay, having said that, let's begin with our session. We all know that when you connect a battery or a voltage difference across any resistance, current starts flowing through it. The battery acts like an energy source, and the resistor acts like a sink where all the energy gets lost. You know, it's like if you're in a running race or a marathon, or if you have ever participated in a cycle race, you always get energized at those counters where they hold that glucose or maybe that juice or some energy drink. Have you seen that? Have you participated in anything like that? I'm pretty sure you have. Hi Tarun, I'm very good. Hi Jyoti, welcome aboard. Hi Sarasthi Thakur, welcome aboard. Yes, they give you that energy drink. That energy drink is this one. And the current is you participating in the running or the cycling race. And then in the slopes or in the curves, you lose that energy. Those are nothing but, those hurdles are nothing but those resistances. Yep, so we have a butterfly as a visitor for our channel. Okay, bye bye butterfly, please go ahead. Okay, so that, understand, resistance is nothing but where the energy is lost. So what is the formula for the energy lost per unit time? So there is a very simple formula. Oh my god. Hi Jyoti, welcome. Hi Mohammed. Yes sir, Shreyas Hebbare hates sports. Oh my god, why do you hate sports, man? You should not hate sports. You should love something. Okay, I hope at least you love something instead of sports. Now the power loss across a resistor, the energy lost per unit time. What's the formula? The formula for, the power lost in the form of heat whenever a current flows through the resistor is given by I squared R. What is I? I is the current. What is R? Resistance. Yes, that's how it is. You can also write it as V square by R or even VI. You can use Ohm's law and you can see it is valid. If you just use V is equal to IR, you substitute it over here, you will get this equation. Similarly, you can put R is equal to V by I, you will get this equation. So all the three equations are the same. I is the current flowing through the resistor, V is the voltage across that resistor, and R is the resistance. You can use any of the formulas depending on what the question is. Okay, I hope this is clear. Okay, great. Glad, Premchand, you have become confident. Don't worry, bacha, and I'm going to make you even more confident by the end of this series. Stay with me. Yes. Okay. So, Enthuse FC, from today onwards, all the homework answers will also come with solutions. Yes, they are also going to come with solutions. So, when you download the Telegram PDF, you'll also get the solutions. I have heard you. Yes, Ankit Kumar, whatever question you have, please ask me. Yep. Glad, Sakshi. Ray optics revision. Premchand, I have already done a ray optics revision in 0 to Hero series. So please check out the playlist, bacha. And if you still cannot find it, just write a comment after the video. I will ping you the link of it, or ping me on my handle, Instagram handle, Shreyas_Vedantu. I'll definitely help you out. Okay, let's solve a problem. An electric heater conducts 4 amperes current when 60 volts is applied across the terminal. Heater, alright, is based on the principle of this heating. Whenever you pass current, the resistance develops some heat and it heats the water in turn. How much heat is generated in just 1 minute? Come on, let's see how many of you can do this. Okay, come on. Think. Come on, guys. Yes, come on, start solving. I hope your notes are out. I hope your pen is outside, and I hope you have already started solving. So the formula that you should use for this is power is voltage into current. And what is power? Lost. It is nothing but the heat lost divided by the time. Yes, that is voltage into current. So therefore, the heat lost is voltage. Voltage is 60 into current. Current is nothing but 4. into time. Now do not put time as 1 minute. It is 60 seconds. Put it in SI units. Be careful. Yes, be careful guys. It is 60. I know a lot of you make that mistake. Look at that. Sunita made that mistake. Yes, Ankit says give 1 minute. Ankit, are you trying it out? You want 1 minute to actually heat it up and you want to check out how many joules are being consumed. Okay. So, hi Surya, good evening. Welcome aboard. Start solving. Welcome to the Pathfinder series. Yes, a lot of people forgot that 60. A lot of people forgot that 60. I can see the chat box. Yes. And that's why the answer is 1440 joules, which is 14.4 kilojoules. That's a huge amount of heat which will be generated. Yep, beautiful. And sometimes you know what can happen. Sometimes they might tell you how much is the increase in the temperature of that liquid. They might ask you that question. So you can have current electricity combined with thermodynamics. 2 chapters in 1 question. How will you solve that? Very easy. This is the heat which will be generated, and this heat will heat up that liquid in which that heater rod has been immersed. So you can just write this is equal to mc delta T. M will be given to you, how much mass of the liquid. Specific heat capacity will also be given to you. The increase in the temperature, you can find it out using this equation. I hope this is clear. Understood everyone? Understood everyone? Chinmay Pense asking for boards, we should write small I or big I. Oh my god, this is a very difficult question. I don't know. Just check it out in your NCERT. If it is small I, use small I. If it is big I, that's big I. You know, these kind of things are very crazy, you know, in boards. They cut marks for stupidest of the things, like small I and capital I. I mean, come on yaar, how much will you trouble the kids? I mean, you should concentrate more on the concept, and you should be worried more about the answers, solving the problems, concept application, you know, logical thinking rather than all these things. So I don't know, just check it out. Whatever is there in NCERT, just use that. I mean, it's crazy. I mean, I have lost marks in my board examinations for the craziest of the things because I used to derive, you know, derive the formulas in the board examinations in my way, and my ways used to be really interesting. And I don't know, I don't think the board examiner ever understood the way I did it, and that's it. I lost my marks. So then I realized, okay, you know, you cannot do that, and I have to follow the book method. So after the prelims were over, and then I used my I skipped my method and I just used the method which was there in NCERT, prescribed by NCERT, and I just used that, and that's how I got some marks. Yep, that's how it is. Okay, chalo, let's get going to the next one coming up on your screen. Okay, but before that, let me also tell you guys that yes, the answer is 14.4 kilojoules. Let me also confidently tell you, and there is some very interesting things. I'm pretty sure most of you would have already heard about it, and that's Vedantu promise. This is very important. I mean, just look at these results. We are not just telling you some random data. This is facts. These are things which has happened in the past. I mean, even if you look at the 12th standard or the 10th standard CBSE marks, the number of students who have scored more than 90% in their board examinations. A Vedantu student is probably going to score more marks than an outside student who does not receive coaching or who receives coaching from somewhere else. So these are the students who might be receiving coaching from some other online or offline institutes. This is the number of students. Yeah, you can see it's 6 times higher. A Vedantu students is 6 times more probable to score above 90% in the board examinations, not just boards, but also JEE Advanced. And looking at this data, we have made you guys a promise, and that is called as the Vedantu Improvement Promise. So when you are a part of Vedantu Pro subscription, we tell you that you are here, you can reach here, and we guarantee you your improvement. And this is happening for the first time in the industry of coaching. First time in this coaching industry, guys. I mean, it has never happened before. It's unprecedented. I mean, think about it. So I feel you should definitely consider joining the Pro subscription. Here, there are 3 kinds of packages: the Lite, the Classic, and the Plus version. You can see all the details about it in the description box. There is a link for joining the pro subscription. I'm pretty sure you have more doubts about it. And if whatever doubts you have, please ping me on my Instagram handle, that's Shreyas_Vedantu. Or you can also write up a comment below in the comment section. I'll definitely solve all your doubts. So go ahead guys, get your guaranteed score improvement. And yes, I'm also teaching in the pro subscription. I'm teaching in lots of micro courses, 11th standard micro courses, plenty of them, 12th standard HC Verma micro course, and also in the 12th standard pro subscription I am teaching. So guys, go ahead. And Shimon sir is also teaching, Wazim sir is also teaching, and it's not just 3 of us guys. There are other teachers who are even better than us, I would say, who are also more experienced than us. All good teachers are there in Vedantu, and you know that. Okay, so go ahead, check it out. Okay, now I would also now go ahead to the next topic, which is bulbs, and let's see what or how to solve the problems on bulbs. A lot of people face issues while solving the bulb problems. Now there is a very simple trick to solve the problems on bulbs. Yes, very simple, and I'm going to enlighten you. Tarun, will you give a tab, sir? Tarun, you don't need a tab. You have your computer, you have your mobile, you can learn from Vedantu using your mobile or your laptop or your already present whatever tablet that you have. Don't fall for those false gimmicks. I know a lot of institutes tell you join our coaching, we are going to give you a free tab. Or they tell you, hey, you just paid our fees. Right now you attend online, and when the offline classes will open up, then you can join offline. Guys, they are overcharging you. How can you charge a student the fees of offline for online classes? You just think about it. They are not using any of their facilities. They are cutting the salaries of so many teachers who are teaching in offline, and then they are asking you the same fees to be paid as a student, as your hardworking parent, all right, to these institutes. And they say that, okay, we are going to teach you online, and when the offline classes, whenever they resume, you can join it, but you know how things are around. That's definitely not correct. I mean, and you can see the Vedantu prices. It's really cheap. I mean, it's 1/5 or 1/4 or 1/6 the price of a regular offline class. I mean, 50,000 for 2 years or almost. I mean, that's something which is unheard of. Now, the trick for solving bulb problems. The trick. Understand, whenever you have a bulb, you might be generally given 2 things. One is the rating, power rating in watts, and the second thing is the voltage at which it generally operates. So 2 things generally will be given to you, the wattage and the voltage. What does it mean? It means the bulb is exactly like a resistor. It's like a resistor which has some resistance, and the resistance loses heat or loses energy in the form of heat at 100 joules per second or 100 watts when you apply a voltage of 200 volts. So it's just like a resistance. It's just like Sai Teja. You can check out all the details in the VIP link. It's there in the description box. You can check it out later on. Okay, so let's continue. Yep. So now Mohammad Praul sir is not in pro right now. Okay, I hope you know that he has left Vedantu. Yes. Okay, so guys, understand that a bulb is nothing but a resistor. So if I say 100 watts, 200 volts, it means 100 joules per second is lost across a resistor connected across 200 volt battery. Now let me tell you more about this. Just imagine if I use this formula. Power is equal to V square by R. Okay, if I use this formula, what will I get? The power is 100 watts. Voltage is 200 volts. So 200 square divided by R. Correct? So from this, I am going to get the resistance is nothing but 200 square divided by 100. How much is it going to be? 2 square is 400 square by 100. That means 100. So it's going to be 400 ohms. So the resistance of the bulb is 400 ohms. You can even find out the current flowing through the bulb. How do you find out? Using Ohm's law. So if you use Ohm's law or even you can use power formula, that's also okay. So V is nothing but 200. So 200 is equal to I multiplied by R, which is 400 ohms. So current will be 0.5 amperes. So two pieces of information I got, that the resistance is 400 ohms and the current which is flowing through the bulb is 0.5 amperes. That's what I got. Great. Yes, in fact every appliance has an equivalent resistance. Yes, correct. Abhishek, yes, I think you are late today. Okay, Viramani Peru, whatever doubt you have, maybe you can just ask it, or if it is not relevant to the topic right now, just post it or send me across that doubt on Shreyas_Vedantu. I'll try and answer it. Okay, just do that. Now I want you to notice one special thing. Remember this. If you change the voltage, or if you change, decrease or increase that voltage, understand the quantity which does not change is the resistance. Yes. The resistance of the bulb won't change in spite of increasing or decreasing the voltage. It's like a resistor. Obviously, if you increase voltage, what will happen? Current will increase. If you decrease voltage, current will decrease. Power will change, but the resistance won't change. Understand? So, if the same bulb, which is rated at 100 watts, 200 volts, is now connected to 400 volts. If you now connect it to 400 volts, then what happens? We just saw that the resistance was 400 ohms. And the old current, what was that old current, guys? The old current was 0.5 amperes. This is what we saw. Now, in this current situation, what will happen is that there will be a new power V square by R. This V will be 400. So you have to put just 400 square divided by R. R is nothing but 400. So this is going to give you, come on, 400 square by 400 is nothing but 400 watts. Yes, this is the new power. The new power is no longer 100 watts. Look at this. This 100 watts was that old power. This was old power for this voltage. For 200 volts, it was 100 watts. For some other voltage, which is 400 volts, it's some different power. If you use different voltage, this power will also change. I hope this is clear. Yes, but what will not change is the resistance. In fact, the current will also change. You can use V is equal to IR. V is the new voltage. This is the new voltage. Current, resistance will not change. It will still be 400. So current will be 1 ampere. You can see this is the new current. This is the new current. The old current was 0.5 amperes. So this is something which I want you to keep in mind. Treat bulbs like resistances. The problem gets solved. Remember, when you change voltage, then resistance remains same. If you remember this, all problems will be easily solved. Let's start solving some questions based on this. A lamp is marked 60 watts, 220 volts. If it is now operated at 200 volts, then the power consumption will increase, decrease, remain same, or first increase and then decrease. Lakshita Mirasi, hello bacha, have seen your comment. Please don't spam out here. Okay, so Arvind Arora, what I have done is that I have used V square by R formula. That's it. Just I have used that V square by R formula, keeping R constant. For new voltages, I have used that new voltage and found out the new power. That's it. Okay. Sir, your sessions mains level or advanced, give me promise. Saiteja, if you're talking about on YouTube or on pro subscription, no matter where you go, my sessions are mains plus advanced. It's not for mains. It's not for only advanced. It's for mains plus advanced. All kinds of questions will be there. Simple, hard, everything. There will be revision sessions. There will be advanced solving problems. There will be previous year questions, everything. So once I complete the theory, you know this. For all the 2021 students, how much we have struggled. We started our channel in October, and from October, for the students who are writing the examination this year, even now we conduct 0 to hero series, flash series we conducted mock tests, we conducted sure shot 60, so many things. We are going to do the same thing. In fact, even more for you guys. We'll improvise. Okay, a lot of you are saying C. Some of you also said A. Well, guys, that's wrong. C is wrong. A lot of you said unchanged. That's not correct, guys. Oops, I think I went to the next problem. Just 1 second. Yeah, so the answer is decrease. The reason for that, See, if you change the voltage, resistance won't change. Resistance is still the same. Keep this in mind. But power formula, what is the power formula? It is V square by R, right? If R does not change, if only voltage changes, power will change. Now look at that. The old voltage was 220, the new voltage is 200. So what has happened to this V square? It has decreased, right? The voltage has decreased. So what will happen to the power? The power will also decrease, hence the answer is A. Keep this in mind. Okay, I hope this is clear. If they ask you what will happen to the current, if they ask you what will happen to the current, then use V is equal to IR. Now remember, R won't change. R will not change. So if voltage decreases, current will decrease. That's how things work. Keep this in mind. You will never get this wrong. I have told you again, bulb is a resistor and the resistance does not change. Keep this in mind. Next question coming up on your screen, and here it is. Thank you, Sachinanandayam. Thank you so much, guys. And please show your support by smashing that like button out there. It means a lot. Yes, trust me. I get all the motivation for teaching out here for free of cost, only through your likes. That's your only fees for joining this channel. Yes, come on. Okay, very good, Neha. Very good, Akriti. Very good. Okay, Ankit has started answering. Hi, Surya Nagaraj. Welcome aboard. Okay, no problem, Akriti. Just join in. Whatever part you missed initially, just watch the replay. Don't worry, this is the later part and we are going to start with something new also. So from where I came, I can remember these formulas. Good, Arvind Arora motivation. Please attend the classes regularly, bacha. You will get a hang of all these sessions. Hi, Pratham Grover. Okay, come on, come on. Hi, Khatir Aman. Come on. So Abhinav Aditya, both type of questions are asked, bacha, NCERT based as well as HC Verma based. It's a very important book, HC Verma, for mains as well as advanced. Okay, B, a lot of you are saying B. Well, let's have a look. Let's have a look. First they were in series and now they are in parallel, guys. Now let's draw the diagram first. Okay, where is it? Yeah, here. So earlier, I'll just show one resistor and it is rated at 40 watts and 200 volts. So this was 200 volts and this was 40 watts. Great. We can also find the resistance using the formula P is equal to V square by R. So power is 40, V square is 200 square by R. So this gives me R is 200 square by 40. No need to solve this. You will see why. No need to simplify. You will see why, because I'm going to substitute it somewhere else. Now the second time, there are two such bulbs connected in series across the same voltage. That means you have similar identical resistances. If this resistance was R, now you have two such resistances, R and R. But they are connected across 200 volts. That means each bulb has 100 volt and 100 volt difference. Be careful, in series voltages are not same. In parallel voltages are same. In series the voltages get added up to give you the total voltage. Now since the bulbs are identical, resistances are identical, hence the voltage drops are identical and hence each one of them will have 100 volts each. Now use this formula, P is equal to V square by R. This is the new power. So the new power will be, understand, the new voltage square. And remember, resistance never changes. Resistance is always same. So R is R. Now substitute the value. What is the new voltage across each bulb? The new voltage is 100 square, guys. Resistance, substitute it from here. It will be 200 square divided by 4. That's the reason why I told you keep this R in this form, because I know a lot of things are going to get cancelled. So what will happen? That 4 goes on the top and this will be 1 by 2 square. So that's going to be, yes, I hope, oh sorry, that was 40, my bad. This was 40, yes. This was 40, resistance was this thing divided by 40. So this is going to give me 10 watts. That's the new power. Yes, that's the new power, and you can see the option is D. I think a lot of you got it. Yes, a lot of you got it wrong, I guess, because a lot of you answered C. That's wrong. I know a lot of you thought this. Oh, 40 watts, 200 volts, 2 bulbs in series, divided, sir. Come on, equal 40 divided into 2, 20, 20, sir. Obviously, 20, 20 is 40. Wrong, it's not like that. It's not like that. Look at this. That's why you need to know the concepts. What is happening behind the scenes. If you understand the concepts, what is running behind the scenes, only then you can get this answer. Else you will write 2020. Okay. Okay. I hope this is clear. Yes. 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 Okay. Oh, by the way, Ashara, be careful. The question was not find the total power. The question was power across each bulb. That's why I have considered only one resistance. Excuse me. What about electrostatics? Sai Teja, please check the previous videos. Electrostatics is already done. Okay? It's done. Yeah. Gauss law is also done. Okay. Okay. Let's get going to the next question. Yep. And the next concepts which are going to come. Okay. Let's see. Yeah. The answer was 10 volts. Oh, by the way, let me tell you one very interesting news. Because a lot of you are asking, sir, should I refer H.C. Verma? Should I refer NCERT? Yes, you can refer NCERT, you can refer H.C. Verma, you can refer Physics Galaxy, you can also refer Jagdamba, you can also refer Pradeep, you can also refer Cengage, you can also refer DC Pandey, you can also refer previous year's book by Disha Publications, you can also refer this material, that material. Guys, how much are you going to do? You cannot do all that. Please understand, refer only one book. If you want, yes, there are lots of books you can buy. You can do some weightlifting using all these books. But there is one book which has almost all the concepts, all types of problems, previous years, simple problems, and then advanced questions, previous years means previous years advanced, and challenging questions, along with important definitions, important formulas, pointers to remember, summary of the chapter, all in one booklet. All in one booklet. And guess what? It's there both as soft copy as well as hard copy, which will be couriered to you. Now, if you want the courier of the Tattva material, yes, you need to be a part of the pro subscription. You are going to get both the soft copy as well as the hard copy. So go ahead and please check it out in case you are a part of pro subscription. Wait for it. Everything is getting delivered. Some of you might have already received your Tattva material. Okay, now let's talk about combination of resistors. Tattva is not available for free, bacha, music stories. I mean, come on, it takes some price to print it. It has taken a lot of efforts over the years to actually make that material. So obviously it's not for free. Okay. I mean, if everything comes for free, then nobody will work, right? How can you get everything for free in life? Obviously that's never possible. I'm pretty sure you are going to also do a job and you are not going to work for someone for free. I mean, that will be crazy, right? I mean, I'm pretty sure your parents too might be working somewhere or might be running a business. Obviously, yes, you need to, when you're working, obviously you need to get paid for whatever you're worth. And that's how things work in life. Is Cengage okay for studying Sachinandana? I do not like Cengage. Yep, I do not like. Okay. Now let's talk about combination of resistors. Now the first thing that I want to talk about is series. Let's do this quickly. Everybody knows this. When resistors are in series, the equivalent resistance Rs, will be just the addition of R1 plus R2 plus R3. You have studied this in your 10th standard. Some of the most important pointers for resistors in series is that whatever current flows through any one resistor, the same current will flow through all the resistors. So the first important point, same current, all right, flows through each resistor. Through each resistor. This is your first pointer. Next pointer, yes, this equivalent resistance is more than each of the resistance. It's more than each resistance. Very important, because you can see RS is R1 plus R2 plus R3. So obviously RS is more than R1, RS is more than R2, RS is more than R3 or any other such resistor out there. Yes. Next, what is the next important pointer? The next important pointer is when you add the potential difference across each resistor, then you get the total potential difference. That means voltage difference across this plus voltage difference across this plus voltage difference across this will be the total voltage. Makes sense. 5 volts difference here, 4 volts difference here, 2 volts difference here. So 5 plus 4 plus 2 will be the total voltage. Last thing over here, which is very important for you to note, is that the potential difference across a resistor, the potential difference across a resistor is directly proportional to, use Ohm's law, V is IR, V is IR and current is same. That means the voltage is directly proportional to that particular resistance. Yes, it's directly proportional to that particular resistance. Keep this in mind. Everybody clear about this? Yes, the voltage gets distributed. Yes, Frederick, correcto. Gopal Krishna, why only Tattva? Is there no other books? Gopal Krishna, yes, there are lots of books, but how many books are you going to refer? If you want one book which contains all kinds of problems and you know the important pointers, that is Tattva. Let me tell you that. And all our toppers have been using Tattva only. Okay, so I hope this is clear. Very good, very beautiful, amazing. Mohammed, yes, it will definitely help you for NEET as well. Okay, now this is very important. This is something which is skipped and ignored by a lot of coaching institutes. Potential divider arrangement. When you have multiple resistors in series and you can see the total voltage across them is V volts. You can see the total voltage drop or potential difference, voltage drop. Okay, what is it? It is nothing but, drop is nothing but V volts. Then if you want to find the voltage drop across any one resistor, doesn't matter, anyone, maybe let's say for example R2 and I call that V2, that will be given by, think first, the current flowing through that will be I, correct? The current flowing through all of them will be same and it will be I. What will be the current? Current is voltage divided by resistance. What is the voltage? Total voltage is V, total resistance is R1 plus R2 plus R3 plus R4, the total resistance. This is the current, total voltage by total resistance. Now the voltage across this resistance will be current multiplied by this resistance. Isn't that obvious? The voltage across this resistance is current into resistance of this guy. So this current multiplied by R2. That's how it works. That's how it works. Yes. Okay. Pavitra Khare, you will be timed out, bacha, for spamming out here. Yep, I'm just spamming you out. Okay. Yes, please don't spam. Okay. So guys, similarly, if I had asked you what is the value of V3, then what would you do? Total voltage divided by total resistance. First do that. R1 plus R2 plus R3 plus R4. Multiplied by which voltage you want to find? Voltage across R3. So just multiplied by R3. This is very important formula. I hope everybody has understood the potential divider arrangement formula. Why is it called potential divider? The potential gets divided into all the resistances. So if I want to find the potential across any one resistor, then use this formula. Total voltage by total resistance multiplied by that resistance. Great. Great. This is very important. Now I can give you one more example for this. Say you have this question which says this is 10 volt and maybe this is 3 ohms and maybe this is 2 ohms and this is, let's say, obviously ground, that means 0 volts. And then they ask you, hey, come on, tell me what is the voltage over here? Okay, what is the voltage drop over here? So how do you find the voltage drop? Well, it's very simple. The voltage drop can be found out by the total. Can you see these are resistors in series? 1, 2, 3, 4. Yeah, there are 2 resistors in series. I hope you can see that. And the total voltage across them is 10 volts. Use my formula. Total voltage 10. Total resistance 3 plus 2, which is 5. Multiplied by this resistance. What is that resistance? 2. So it will be nothing but 4 volts. So it will be 4 volts. Is that clear? Abhishek R, you can ask me all the other questions later on, not now. Right now the session is going on. Please post all your doubts on my Instagram handle or after the session ends below in the comment section. I reply to all the comments out there. Okay, great, great. Yes, beautiful. Now let's solve next few questions, but before that, the parallel related formula. Yes, let's solve the parallel related formula. And remember, when you have multiple resistors and they are in parallel, the equivalent resistance is given by this formula. Everybody knows this. 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3. Now the most important pointers over here. First pointer. Okay, keep this in mind. If there is a current coming, that current will get divided into all these resistors. Understand? This current gets divided. You're just replacing these resistors with one single resistor over here. So the first important pointer is the sum of currents in each resistor. In each resistor is equal to the total current. That's equal to the total current. That's number one. Number two, each resistor has the same voltage drop. And you can see why I'm saying that. If I tell you this is V1 volts and if I tell you this is V2 volts, each resistor has V1 minus V2 voltage difference. So the potential difference is same across all of them, is same for all. Keep this in mind. That's the second important pointer that you should note. Okay, I hope this is clear. Yes. And the third important pointer, remember the current in a resistor, the current in a resistor is proportional to V is equal to IR, V is equal to IR, but voltage is same. So that means I into R is constant. Think about it, V is equal to IR, V is same. So I into R is constant. That means I is inversely related to R. So the current is divided in the inverse ratio. It's divided inversely to the resistance. Keep this in mind. So current into resistance is constant, or current is inversely proportional to resistance. Correcto. Beautiful. Beautiful. Yes. Okay, come on guys, focus. Yes. Yes. Glad Ankit. Ankit, just mention the student name also whenever you are writing so that it is very clear. Sometimes there might be some misunderstanding. Obviously, Fiesta Vista, you should do vectors. Obviously, you should do vectors first. Okay. Now, let's see whether you can solve this question. Find the effective resistance in the given circuit between points A and B. Come on, let's see. This is an easy one. This is just a warm-up question. Yes. Frederick, no, voltage does not get distributed. Current gets distributed in parallel. Be careful. Okay. Madan Chavan, I'll just block you if you spam once more. Come on, all my warriors, think about it. Come on, come on, come on. Find the effective resistance in the given circuit. Yes. Okay, Vijay Kumar, glad you're back. Come on, come on, come on, come on. Okay, Madan Chavan, last warning done. So I'm putting you on timeout. Okay. Okay, some of you are saying C, some of you are saying D. Okay. Well, the correct answer is actually C, guys. And it's very simple to see. Why it is C? Because this 10 and 10 are in series. And if they are in series, their resistance will be 20 ohms. This 5 and 5 are also in series. So their equivalent will be 10 ohm. Now this 20 and 10, what are they in? They are in parallel. So that's why 1 by R equivalent will be 1 by 20 plus 1 by 10. So this is nothing but 10 plus 20 divided by 10 into 20. And if you know, there is a direct way of doing this. R is R1 R2, which is 10 into 20. 10 into 20 upon 10 plus 20. You can do this directly. R1 R2 upon R1 plus R2. So this is going to give you 6.66 ohms. Beautiful. That's the answer. Excellent. A lot of you would have got this. Great. Great. Let's get going to the next one. Okay. Now, find the current in each branch. Let's do this question. Let's do this question. Now, whenever you have to do these kind of questions, what you should do is first simplify the circuit. Yes, step by step. Now, how do you simplify the circuit? These two resistors, you can clearly see they are in parallel. So therefore, when I combine them, you will get one single resistance, and then this resistance is as it is, and you will connect it across the 10 volt battery. So this resistance is 3 ohm. Now this 3 and 6 are in parallel. What's their equivalent? Think about it. It will be 3 into 6, R1 R2 divided by R1 plus R2. 6 3s are 18, 6 plus 3 9, so this will be 2 ohms. Obviously this will be 2 ohms then, correct? And lastly, this 2 and 3 combine together into one single resistance, and that would be how much? That would be 5 ohm. 2 plus 3 is 5, and that is connected across 10 volt. Okay. Now, if you have got this, what you should do now is whatever steps you did to simplify, go back from the last step to the first step. Yes, that's the trick. So guys, if 5 ohm is connected to 10 volts, what will be the current? Current will be voltage divided by 5 resistance, which will be 2 amperes. Yes, 2 amperes current will flow here. Now, this resistor is split into 2 resistors in series. What did I tell you? In series, current is same. So therefore, whatever current flows here will also flow over here. Yes, 2 amperes will still flow over here. Understand that. Okay, so there is no doubt about it. This resistor will have same current, 2 amperes, 2 amperes. Now, understand this resistor 3 ohm will still have 2 amperes. But this 2 amperes which enters from here will now get split into 2 parts, I1 and I2, because it has to get split, right? It's in parallel. So remember that trick which I told you? Current is inversely proportional to resistance in parallel circuits. So just do that. I1 by I2 will be 6 by 3. I1 by I2 will be 6 by 3, inversely related. I1 3 and I2 6, inversely related, which is nothing but 2:1. Now what you can do is, you can just use componendo. Just use componendo. Okay, componendo I1 plus I2 divided by I2 will be 2 plus 1 divided by 1. What will be I1 plus I2? I1 plus I2, the total current. Remember I told you the total current is sum of all the currents. So that's why I1 plus I2 will be 2 amperes. I2 will come as it is. This will become 3. Yes. Yes. I hope this is clear, guys. Yep. Componendo, dividendo nahi. You just have to use componendo. Understand that. Yep. Yep. You just need to use componendo. Yep. I hope this is clear. Great. And then I2 will come out to be, what will I2 come out to be? It will come out to be 2 by 3 amperes. Yes, I2 will come out to be 2 by 3 amperes. Correcto. And last thing, once you know I2, you can easily find I1. Obviously, what will be I1, guys? Think about it. I1 will be 2 minus 2 by 3. So this will be 3 2s are 6, 6 minus 2, 4. So it will be 4 by 3 amperes. Yes, 4 by 3 amperes. So 2 by 3 amperes, 4 by 3 amperes. So this is the method. I'll just repeat what we did. Whenever you get a complex circuit and you want to find the current through each branch, first simplify the circuit, find the current in the final circuit, and then go back, trace back, keep on going each step and find the currents in each branch. That's the way to solve the problem. Great. That's the trick, guys. Okay, beautiful. I think the answers given over here are wrong. Let me just correct this. This was not supposed to be 0.5, guys. Yes, this was supposed to be 2 by 3 and this was supposed to be 4 by 3, so that you get the correct answers in the PDF. Yep. Okay. Okay, now resistance in disguised form. This is the next important trick. See, now basic series and parallel you will be able to solve. That's not a big problem because you have done that in 10th standard also. Now I want to show you some special techniques for solving the problem. Let's have a look at it. Should we convert it into decimals? Depends, Frederick. If it is an integer type, yes. If it is given in the options, yes. Else you will not do that. Yep. Yes, Scooby-Doo. Yes, how many of you have watched it? Sakshi, please take care of yourself and your health, bacha. Please don't strain too much. I'm so happy that you are even watching while you have fever. But yeah, sit comfortably, please take care, keep yourself hydrated, keep yourself in check. Yep, a lot of you have done that. So this is disguised form. You know what is going to happen? There will be a circuit. It will be like a villain. It will look very difficult. You will be like, oh my god, how to solve this? But actually when you remove the mask, you'll understand, array, it's such a simple circuit. So that's called as disguised form. Now some of the tips and tricks you should keep in mind. These are the 3 important things to keep in mind while solving these kind of disguised problems. Number 1, mark the potentials. This is V volts, this is V1, this is V2, this is 0. You can assume something if it is not given or if it is not known, but try to mark as many potentials as you can in the circuit. That will give you a clarity, a clear picture of what might be happening. That's the first thing. Second thing, keep this in mind, whenever resistors are in series, then what will happen, guys? Same current will flow. Correct? Whenever resistors are in series, same current will flow and the potential difference will add up. Yes, V1 plus V2 plus V3 will be total voltage. That's for series. And for parallel, well, for parallel, the current will get distributed, that's standard, and they are going to have the same potential difference. So keep these pointers in mind to solve the problems. Let's do a problem so that you get a hang of it. Yep, let's do this. Now, find equivalent resistance between points A and B. Look at this circuit. The question is to find the equivalent resistance between these 2 points. Here is what I'm going to do. Here's what I'm going to do. Let me mark the potentials at different points. Let me just mark. Okay. Let's say I call this V volts. Okay, let's just call this as V volts. How much will this potential be? Come on, my warriors, answer this. Do you see there is a wire in between them? Come on, what will be the potential at this point? Hello, good evening, Ashwini Babu and Rashmi Prishti. Many happy returns of the day. Rashmi, do well, stay safe and maintain your health. And yes, all the best. Okay, it will be V. Beautiful. Exactly. Now let's assume this has 0. It doesn't matter, guys. I mean, this is 0. How does it matter? Okay, this is 0, this is V. You can assume it as V1 also. It doesn't matter. If this is 0, this will be also 0. Okay, this is also 0 volts. Now, this one over here, okay, this one over here will be something else because it's not connected to any of the other things. So let's just assume it as V1. Okay, let's just assume it as V1. Now, do you see some resistors having the same voltage difference? I think I see that. Look at this resistor and look at this resistor. Voltage difference is V1 only. V1 minus 0, V1 minus 0. And you can see the current is getting distributed. That means these 2 resistors are actually in parallel. So I can actually redraw the circuit. And how am I going to redraw the circuit? Look at this. This is point A. Okay, this is the resistance on the top. This one, this resistor is this. And this resistor below is over here. Okay, and this resistor is in parallel with that. So I'm just going to draw a resistor in parallel with this like this. And this is connected to point B. This is connected to point A. Now there is only one resistor missing, and that is this one. Look at this resistor. It is connected across V, which is at point A, and the next one is connected across B, which is point 0 volts. So between B and A, guys, so I think this is what it should look like. Just check this out. This is also R. Yep, this is this resistance. Everybody agrees? Just everybody agrees to this? Yep, everybody agrees this is how the disguised form is. So when you remove the mask, this is exactly how it looks like. Now this problem becomes very easy. You can see these 2 are in parallel. So what will be the equivalent? R into R divided by R plus R. That will be R by 2. R by 2. How 0 in B and C? Guys, there is a wire. Who was that? V Enthuse FC. Look at this. There is a wire connecting both of them. So in a wire, there is no potential difference. So whenever you connect a wire, all the points have the same potential. Just like over here between A and D, they are connected by a wire. So both these points have the same potential. Okay, Sakshi, Gandhi Jayanti is your birthday. Very good. Now this resistance R by 2 and this resistance R, they are in series. How 0 in C? I have just assumed B is 0. If you do not like music stories, 0. If you do not like, assume this as V2. How does it matter, bacha? Assume this as V2. So then this will be also V2. Doesn't matter. Just assume it as V2. Yes, you can take V2, V3 also you can take. Both of them will have same. Whatever you take at B should be there at C. Understand that. Because there is a wire connecting them. And what is important is between this resistor and this resistor, the voltage difference is the same. V1 minus V2, V1 minus V2. So hence both of them are in parallel. That's what I have shown. I hope this is clear. Yes, you can take V3 also. No problem. Great. And now these two are in series. I hope you can see both of them are in series. So guys, what will happen? If this and this are in series, so let's redraw the circuit. You will get one single resistor here and you will probably have a resistor here like this. And this is going to be B, this is going to be A, this is going to be R. What will this resistor be? It will be R plus R by 2. R plus R by 2, which is 3R by 2 because they are in series. Yep, this one and this one are in series. And the last one, yes, these two are in parallel. So combine them into one single resistor. These two are in parallel. So 3R by 2 multiplied by R divided by 3R by 2 plus R. What is it going to give you? A lot of R's are going to get cancelled. I hope you can see that. This R, this R, this R. And this 2 and this 2 will also get cancelled when you put that 2 over here. So what are you going to get? Come on guys. You're going to get 3R by 5. Yes. Oh, Aishwarya, I think you put that R below. Yes, that R should be on the top. Yep. Great, great. Jagdish, I'm coming to infinite circuit problem. Just hold on. I'll do everything. Okay, don't worry. Yes, 3R by 5. Understood how to solve the disguise problem? Let's do one more disguise problem. Are you guys ready? Are you guys excited to solve one more problem? Yes. So, Giridhar and PV, we are going to give you homework questions. And for assignments and more questions, Tattva module and Pro subscription will give you more assignments. Okay, so that's what you will get in the Pro subscription. You'll get the assignments after every session plus the Tattva module. Yep. And here you're going to get homework problems and all these questions you can download it as a PDF for practice. Okay, let's see the next question coming up on your screen. 3R by 5 was the answer. Look at this question. Yep. Come on. Let's see this. Look at these questions. Look at these resistors. Look at these wires. Try to think what will be the equivalent resistance between A and D. Let's do this. Come on. I hope you have started marking the potentials already. So let's say this is a battery. This is 0 volts. This is V volts. Okay. Let's just mark the potentials. This is 0. This is V. If this is V, obviously this is also V because there is a wire. So this is also V. Remember, I can take it as 0, you can take it as anything else also, doesn't matter. If this is 0, then obviously this point is also 0 because this is only one wire. Yep. Now, resistance cube, Jagdish will do it after Kirchhoff's current law and voltage law. Not now. Okay, for that you need Kirchhoff's current law and voltage law. Hold on for that, that's going to happen after next lecture. Now, look at this. There is again a wire over here. You can see there is a wire. So this is V. Even this point is V, guys. So this is V. This is V. Even this is V. This is 0. This is 0. There is a wire over here. So this is also 0. I hope you can see that. This is 0. This is also 0. This is V. Yep. You can see all these points. Now, guys. Mohammed, if there is too much time, then you can do one thing. You can take a pause, take a break. You can watch the lecture later on. Okay, bacha? Okay. Now, do you see all the three resistors? What is their common potential difference? Look at that. 0 V, 0 V, 0 V. All the three resistors. All three resistors have same potential difference of how much? V minus 0. Yes, that's the potential difference. That means, correct, they are actually in parallel. It doesn't look like they are in parallel. You might think, what nonsense, sir, they are in series. No, they are not in series, they are actually in parallel. It has been disguised. If you rearrange it, then you will see that they are actually in parallel. So hence, R equivalent, 1 by R equivalent will be 1 by R plus 1 by R plus 1 by R, which is 3 by R. Therefore, R equivalent will be R by 3. That's the answer. Correcto. Shreyas Paliwal, we are giving full content on YouTube for free. What more you want? But yes, there will be many more sessions which will be available on the pro subscription. Obviously, that will come at a price. Everything can't be at free. Understand that. Because we need to also maintain and feed all our teachers. If everybody does everything for free, what am I going to eat? How am I going to pay the bill? How are you going to use this board? How am I going to pay for anything? How am I going to feed my family? How is the person who makes the content survive? How is the person who manages the channel going to survive? How is the person handling your chat going to work? How is the person who is working in the IT team going to survive? How is the person who is handling all the technical things, all the HR, the admin, everybody going to work? They all need something for their bread and butter. Understand? So the charges for the pro subscription are nominal. So I hope you get my point. I hope you get my point. Yep. Great. So this is R by 3. Let's go to the next question coming up on your screen. Now this is infinite question. Yes. Let's redraw. Yeah, you can redraw if you want. You can redraw it. It's not a difficult task. Let's solve this problem, infinite ladder. Now for infinite ladder problem, what you need to do is understand one simple fact. The simple fact is that first identify whatever repeats itself. Just try to look at the diagram, see what is repeating itself, and remember one thing: infinity plus 1 is infinity, and infinity minus 1 is also infinity. Infinity plus 1 is not more than infinity. You cannot compare two infinities. That's wrong, mathematically incorrect. And infinity minus 1 is also infinity. So when you have infinite, countless things, you take away one thing, it doesn't matter. You add one thing, doesn't matter. Keep this in mind and solve the problem based on that. Yes. Now, look at this problem. Let's try to figure out what is the equivalent resistance. Okay. So what we are going to do is we are going to assume the repeating pattern. We are going to add one more pattern over here because infinity plus one more pattern will not make a difference. And whatever is over there, we are going to assume it to be some unknown, and then we are going to solve. If you did not get it, don't worry. Let's look at the problem. Yes, adding or subtracting a repeating pattern and find the equivalent resistance. Let's figure this out. Okay, just look at this problem. Look at this problem, 4 ohm, 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 till infinity, goes on. Yes, let's look at this. Shreyas Bacha, if you can't afford, don't worry. You can watch all the lectures over here. Second option, use the EMI option. In EMI option, you don't have to pay the full amount. You can only pay 3,000 to 4,000 rupees per month. That's it. Okay, great. Now, the pattern which is repeating over here is this one. This is the repeating pattern. I hope you can see. This is the infinite thing. Add one more thing over here. It won't make a difference. Just add one more thing over here. It doesn't matter. Infinity plus one more thing will not matter. That's the logic. So this is 4 ohm and this is also 4 ohm. I hope you understand. This circuit will have some equivalent resistance between them. Let's say the equivalent resistance is X. This equivalent resistance which we need to find is X. Now, do you also agree that this circuit is similar to this circuit with 4 ohm, 4 ohm? Okay, these 2 points are as it is. Whatever is there in the black, which is infinity, can I replace that also with X? Think about it. Whatever is there in black, I mean, just if I hide it, you can see, isn't that also X? Because if you look from here, this is an infinite ladder having equivalent resistance as X. So if you start looking from here also, that should be X. Do you see that? Do you see that? Yes. Glad, Shreyas. Did you see that? Did you see that? Jitendra Prasad, every day I come live at 7:30. Now, if you have understood this much, that's it, the problem gets solved. Aren't these two resistances in parallel? Aren't these two resistances in parallel? So what will happen, guys? You are going to get a 4 ohm over here, and this resistance, what will this resistance be? Parallel, right? So 4x divided by 4 plus x. 4x divided by 4 plus x. And this is in series with this 4, which gives back, which again gives back x only. Remember, the equivalent resistance was x itself. So can I not say this 4 ohm is in series with this resistance 4x by 4 plus x, which gives back x only, which gives back x. Everybody understanding? Everybody understanding this? Correct. I think Aishwarya Gandhi has already figured it out. Beautiful. So this is the equation. Now you just need to solve it. Take LCM, multiply. So 4 into 4 plus x plus 4x. Take this 4 plus x over there. So x into 4 plus x. Great. Now this will become 16 plus 4x plus 4x is equal to 4x plus x square. You can see one of the 4x and this 4x gets cancelled. Shift these two terms over there. So you are going to get x square minus 4x minus 16 is equal to 0. You can see this is a quadratic equation. Now I no longer need this, so I'm just going to erase this part out. Okay, so this is a quadratic equation. You cannot factorize it, so use your formula. So x is minus b, b is minus 4. So minus minus will become plus. Yes, plus or minus by 2a, 2 into 1, b square is 4 square, okay, minus 4 into a into c, c is 16 with a negative sign, so minus 16. Great. So can I take out 4 from here? I guess so. So this will become 4 plus or minus. Let's take 4 outside the root. Minus minus will become plus, so 4 plus, I guess, yep. Oh, sorry, this is not 4 plus, my bad. This is 1 plus 4. Yep, 4 square I have taken outside, so it will become 4 over here. Yep, divided by 2, and this is going to be 2 plus or minus 2 root of 5. But negative sign, nah. Why? Because resistance always has to be positive. So therefore, the allowed value will be 2 plus 2 root 5. Because since x is more than 0, you cannot have a negative resistance. I hope this is clear. Yes. Okay, great. I hope this is clear. Yep, very good, very good, very good. Let's solve some more questions. I hope you guys are game for it. One more type of question I want to discuss, that is symmetry problem. It will help you solve a lot of geometries. Okay, are you guys game for it? Yes, 2 plus 2 root 5. That's the answer. Method of symmetry, very important technique. 2 problems I will take. That's it. Okay, let's do that. Thank you guys for all the love and support. Samir, if you have heard that, that is wrong. Because I teach in normal batches. I have been teaching in normal batches plus the topper batch. So I know I teach, yes, advanced level stuff, and the content which we give is Tattva, which has both mains plus advanced, and the assignments tests contain both mains plus advanced level. Tests are also mains plus advanced level. So if somebody has told you that, he or she is lying or just made a fool out of you. Okay, so method of symmetry. Very important type of question. This question is very likely that it is going to come in the examination. What you need to identify? See if there is some symmetry. Something is similar, left and right, top and bottom. See if something is similar. Usually, you will find that there are some points which are symmetrically located. Now, for example, in this circuit, if the current comes here and goes out here, you can see this is the line of symmetry. Can you see this is the line of symmetry? Yes, this is the line of symmetry. So identify that line of symmetry and identify the points on that line of symmetry, like this point, this point, this point, this point. Yes, identify those points. All these points have the same potential. Why they have the same potential? Obviously, because they are at the midpoint. They are on the line of symmetry. So all of them must have the same potential because of symmetry itself. I hope this is clear. I hope this is clear. Is that understood? All the points which lie on the line of symmetry, all these points have the same potential. I hope this is fine. Now, whenever 2 points, 3 points have same potential, what does it mean? No current will flow between those 2 points. When does current flow? When there is potential difference. If there is no potential difference, why will current flow? Think about it logically. Hence, any device which is connected between these points are trivial, means useless. They are useless. You can remove all those devices which are connected between those points. Keep that in mind. So Bela Pokanda Gautam, here is the logic, bacha. See, if I tell you this point is V volts, if I tell you this point is 0 volt, this is V volt, this is 0 volt. All these points are exactly at the center, either from here or from there. Hence, all of them should be at V by 2 volts by symmetry. That's it. So all points have same voltage, V by 2, V by 2, V by 2. So whatever comes in between over here, those are useless components. This one and this one, they are all useless. I hope this is clear. Okay, great. Now let's solve a question. Let's solve this question only. Now we just saw that this point, this point, this point and this point, all of them have same potential. They have the same potential. So who are the useless things? Who are the waste characters? Useless. This one and I guess this one. They are useless. Whatever connects between the same points, same potentials, remember you can remove them up. Now, how will the circuit look like when you remove these points? I think it's going to look simpler. So you're going to have this resistor, you're going to have this resistor, you're going to have this resistor and this resistor out here like this and like this, I guess. Okay, and like this and like this and like this and like this. Okay, yep. So like this something. Yep, this is the simplified version because this part and that part are gone. That part and this part, they are gone. Now this looks simple to me. Yes, this looks simple to me. This looks simpler to me. See guys, aren't these two in series? Aren't these two in series? R and R, 4 and 4, what will it be? 8 ohm. This is also 8 ohm. Do you see this one and that one are also in series? So that is also 8 ohm. Do you see this one and this one is also in series? So that is also 8 ohm. Can you see that? I hope you can see that. That means, let's simplify the circuit and see what happens. The one on the top, I will redraw that one as one single resistor as 8 ohms. This one on the top is one single resistance 8 ohm. The one at the bottom, let me just draw it. That is also 8 ohm over here. It's all connected. Yes, let's all join them. Let's all join them. And in between, what do you have? Oh, this is 8, this is 8. These two are 8. They are in parallel. So what will their combination be? Okay, think about it. There is one resistor here and there is one resistor here and there is one resistor here. This is 4. This is 4. These 4s are from here. These two 4s are these two 4s. What is this resistance? The combination of these two. 8 and 8 parallel. What is their combination? Think about it. 8 and 8. Yes, some of you have answered it. That is 4. 8 and 8 is going to still give you 4. Beautiful. Understood? So 4, 4, 4. What will 4, 4, 4 give you? Think about it. What is 4, 4, 4 going to give you? Is it not going to give you 12 ohms? Is it not going to give you 12 ohms? That means 8, 12 and 8 are in parallel. So R equivalent is 1 by 8 plus 1 by 12 plus 1 by 8. Solve this. How much are you going to get? Come on, answer in the chat box. What is the answer? 1 by 8 plus 1 by 12 plus 1 by 8. What is the answer, guys? Is it 1 by 3 or something else? Come on. Come on. Sonu, these are the types of problems which you need to solve. Yes, beta. 1 by 3, correct. So R equivalent will be 3 ohms. That's the final answer. Beautiful. Yes. So final answer will be 3 ohms. Correct. 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 Beautiful. So that's how you use symmetry. That's how you use symmetry for solving problems. Okay. Last problem for today. Beautiful question. I'm pretty sure, yes, the answer is 3 ohms. I'm pretty sure you want to solve this problem. You'll be like, sir, please tell me how to solve this question. Yes, it's very simple. First of all, do you see something which is symmetric? Do you see something which is symmetric? Jagdish, I have launched H.C. Verma short answer questions in the pro subscription. You can definitely join that. Yes, I have solved all the H.C. Verma short answer questions. And also, if you have any doubt, please ask us those doubts from H.C. Verma in our doubt app. We will be more than happy to solve it. And by the way, some of these questions are inspired from H.C. Verma, Tattva and other books. Let me tell you that. Come on. Yes, there is a vertical symmetry and I can mark those points. First, mark those points. This point, this point, this point. All are at the same potential. So this is useless. This is also useless. Okay. So if it is useless, let's draw the circuit again. So let's just draw the circuit again. Okay, this is this. This is like this, I guess. This is like this, I guess. And you have this one over here. This one over here. Okay, like this, and from here you have this one, and from here like this, and like this, and like this. I guess this is how the circuit looks like without these two people. Each one of them is R, 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 R. Yes, all of them are R's. Okay, now I see something interesting, guys. Don't you see this R and this R are actually in parallel? I don't know whether you saw that. I mean, look at that. The potential difference across this R and this R, and similarly these two R's, aren't they the same? They are in parallel. So in fact, this and this are actually in parallel. This and this are actually in parallel. I hope you can see that. These two are in parallel. Similarly, I hope you guys can also see these two resistors are in series. So it will be 2R on the top, and these two resistors are also in series. So that's 2R from the bottom. So 2R and 2R. Yes. Now let's try and solve the question, guys, and see what does it look like. R and R, 2R from the top. Okay, so I'm just going to put a 2R on the top, and over here, yes, a 2R below. Okay, let's draw that 2R. And what about here? These two are in parallel. So if they are in parallel, guys, what will happen? It will become R by 2, right? R and R in parallel, R by 2. This R and this R are in parallel. So what will the equivalent become? It will again become R by 2. I hope you see that. Now, R by 2 are in series. So what will it become? R, right? R by 2 and R by 2 are in series. So what will it become? R, right? So R, 2R and 2R. Come on. What is the final answer? What is the final answer? Come on. Think and tell me. What is the final answer? R, 2R and R. So 1 by R equivalent is 1 by R plus 1 by R plus 1 by 2R. Yep. I hope you can see that. Yep. R by 2. Oh, where is R by 2? Okay, come on, come on, come on. Yes. Come on, come on, come on, come on, come on, come on. Come on, waiting for everybody to answer this. Acha, final answer. Okay, okay. Yes, come on, guys. 1 by R plus 1 by R. 2 by R. Yes, 2 by R plus 1 by 2R. Come on, 2 plus 1 by 2. That's 5 by 2. So come on, guys. 2R by 5 should be the final answer. 2R by 5. How are you getting R by 2? Some of you are getting R by 3. Guys, come on. What mistake are you doing? Check this out. R by 2 plus R by 2 is R. This was R by 2. This was R by 2. Be careful. Yes. be careful. Kuluri Ganaraju, be careful. 2R by 5. Yes, not 5 by 2R. Yes. Be careful, be careful. Yep, be careful. Yes, be careful. Yep, okay. So, be careful with that. R is not 2 ohms. Yep, be careful. Yep. Sir, there are 2 R's. Where is 2 R's? Yep. I'm not sure, Vamshi, which part you saw. Yeah, I'm not sure which part you saw. There was R by 2 and there was R by 2. R by 2 and R by 2 will become R. Be careful. Yes, 2R by 5 is the answer. Be careful. Yep. Okay. Now this is your homework question. Find equivalent resistance across these 2 points. Find equivalent resistance about these 2 points. Come on. Oh, acha. You meant, there was, I think I understood what you guys meant. Oops. Acha. I'm so sorry. I made a stupid mistake out there. I'm so sorry. Thank you very much. So I think there was 2R here and there was 2R over here. Yep. And there was R by 2 and R by 2 over here. My bad, guys. Sorry. This together was R. So I had to write 1 by 2R plus 1 by 2R plus 1 by R. I'm so sorry. Yep. This was 1 by R equivalent. Correct. By mistake, I wrote 1 by R plus 1 by R plus 1 by 2R. My bad. And yes, 1 by 2R plus 1 by 2R. That is going to be 1 by R, 1 by R plus 1 by R. That's going to be 2 by R. Therefore, R equivalent will be R by 2. My bad. Yes. So that's the answer. Thank you so much. Yes. Okay, Insane Asylum said yes. Happens, guys. Happens. Okay, so that's the answer. Okay, now these are the questions which you are supposed to solve at home and put up the answers in the comment box. This one, find the equivalent resistance across A and B, and this one, find the bulb which will glow brighter when they are connected in series. These are the 2 questions that you need to solve. So remember, if you want Tattva, if you want all your doubts to be solved, if you want to study under me, and if you want to boost your rank, and if you want a promise that yes, your rank will be boosted, go check out the pro subscription course. The link is there in the description box below. Now there are three kinds of packages. One is the light version. In the light version, you get everything, but you won't get doubt solving after the class. So if you want doubt solving, you go for the classic version. Yes, you go for the classic version. And if you want a personal teacher, then you go for the plus version, which gives you a personal mentor for solving all your problems. And you can use the coupon code SHHPRO for availing more discount. So go ahead, check it out. Yes. So Jagdish, if you want mentorship from me, you're always going to find me over here as well as on the Instagram. Yes. So Sonu Roy, you can see the homework even in the, PDF link, which will be posted in some time in the description box or in the Telegram group. In the Telegram group also will post the entire PDF. So those, don't worry about it. Yes. So that's it for today, guys. Thank you very much. And I hope you have realized a lot of kind of questions, a lot of different problems of solving resistances, finding equivalent and all that. Jagdish, just give me your love. That's enough. Okay. So you will get mentorship from me for free. You just be here. Trust me. Whatever questions you have, you ask me in the doubts or in the Instagram. I'll definitely help you out. No, I don't speak Tamil. Okay. So Sonu Roy, if you still want to see it, yes, there you go. You can also watch it in the replay. Okay. You will see it in the replay. The link of the Telegram is there in the description box below. Don't worry about it. Bye bye. Take care, guys. See you. Have fun and see you again tomorrow for the next session, and also for Zero to Hero series if you are a 2021 student. Bye bye. Take care.